All right, 1.4, divide polynomials with remainders. So we're going to talk about how to do this. We're going to do some simple ones first, and then we're going to get into a long division with polynomials, which is pretty interesting. All right, objective students will be able to divide polynomials by monomials and binomials using both long and synthetic division. But let's talk about an easy one first. Now, there's a lot of words in this problem, but I basically stole this structure straight from Khan Academy so that you're ready for it when you see it. It says, let a of x equal this expression. So here's a of x, and b of x equals 6x. When dividing a by b, see a divided by b, we could find the unique quotient polynomial q and remainder polynomial r that satisfies the following equation. It's just a really funky way of saying take a divided by b and write your answer in this format. And I'll show you what that format looks like with this problem here. And then it says where the degree, highest power, or r of x is less than the degree of b of x. So that just means like if the highest power here is 2, then this has to be bigger than 2, right? So it'll have to be like 3 or 4 or something like that. The degree, I mean, the exponent. So let's go ahead and just do this math, but I'm going to show you kind of how we can set this up. Because this is a monomial meaning there's just one term, it's actually really easy to set up, and I probably should have left more space, but I'm going to just go down here and rewrite it. So let's do a of x in blue, and we'll do b of x in red. So a of x is 18x to the fourth minus 3x squared plus 6x minus 4. And we're going to divide all that by 6x. Okay, but here's the deal. Because we are dividing it by just a monomial, right, just one term, what we can do to make this so much easier is we can, instead of having one division bar, we could just put a division bar underneath every single term. So let's just go back a second. Okay, a little bit too far, but this is 6x minus 4. And what I'm going to do is I'm just going to put a division bar here, 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 and here. And I can actually just put a 6x underneath each thing. And now it's pretty easy to divide these because you could just do these each one at a time. So let me show you what I mean. So what is 18 divided by 6? Well, that's just 3. And what is x to the fourth divided by x? Now let's just remember what this means, right? X to the fourth is really like saying x times x times x times x, and x to the 1 is just an x. Well, one of those x's is going to cancel. So a shortcut to this really is just say, well, you have 4 on top, 1 on bottom. 4 take away 1 is 3. There'd be 3 left. So this would be x cubed. All right, negative 3 divided by 6. Well, that'd be 1/2, right? So we could kind of just say like 1/2. And then x squared divided by x, well, that's just x. 6x divided by 6x, well, that's just 1, right? Because anything divided by itself is just 1. But now what we have over here is we have a situation where this doesn't have an x. And in fact, you could think of this as like an x to the 0, because anything to the 0 power is 1. And so, and if this down below is x to the 1, isn't this a situation now where this degree or this exponent up here is less than this one? And remember, that's what they said. Let's go back to the problem. Where the degree of r of x is less than the degree of b of x. So that means this is this. That's r of x over b of x. So I would just write, well, I guess I could actually reduce this negative 4 and 6, can't I? I could definitely reduce that. So we could say that's like negative 2/3. But you would just write it like this, minus 2 over 3x. And on Khan, I'm not actually sure if they want you to reduce or not. So I would think the proper thing to do is reduce, but if for whatever reason they mark that wrong, then your remainder would just be this negative 4. So that's like your remainder. And the quotient part, right, is this whole part. And so now you've got your answers here, right? they're going to ask you on con, they're going to say, okay, what's q of x? What's the quotient? And you would say 3x cubed minus 1/2 x plus 1. And they're going to say, what's the remainder? And that's just the part on top. Now, like I said, I think the proper thing to do would be to reduce, but con may ask for just this number that's on top before you reduce. So I would just, in fact, I'm pretty sure they're just going to want this number here. So just leave it there for now. But like I said, I think the proper thing is reduce, but sometimes we have to kind of accommodate for how con works. So what is the quotient? It's here. What is the remainder? It's there. Pretty straightforward. I know it's a little bit confusing, but just set it up like how I did when it's a monomial and you'll be in good shape. So here's another one for you to try. This one is an x squared. So remember on this one we stopped when the degree on top was less. So you'll see here, this is probably where you're going to stop, is at the 2x, because that's when it's less than x squared, right? That's x to the 1, and that's x squared. So this will probably be your remainder. You can kind of tell that's going to be your r of x just by looking at it. But I'll give you a chance to work it out on your own, and then you can unpause the video when you're ready to check your work. Okay, so once again, we had our a of x, which is this whole thing, and our b of x, which is this whole thing. Let's underline that actually. And I just went ahead and put each term above x squared, right? And I just simplified. 7x to the 6th divided by x squared. Well, 6 minus 2 is 4. So that's just, and 7 divided by 1 is just 7, right? So x to the 6th divided by x squared is x to the 4th. X cubed divided by x squared, well, 3x is on top, 2 on bottom, so 2 are going to cancel out. You have to be left with just x to the 1. And then remember here we get to a situation where the degree, the exponent, is a little bit less than the denominator or the b of x, right? And so that means this is our remainder. So pretty much we just stop and we just put that on top, 2x plus 1 over x squared. So what's the quotient? It's just this first part that divided nicely. What's the remainder? It's this top part that did not divide nicely. That's all there is to it. I know this whole phrasing could look really confusing, but really this is all they want you to do, and it's really not that bad. All right, what I want us to do now is I want us to go back in time. Let's go back in time to 4th grade, and I want to talk about long division. And look here, I put a long division problem here. We have 128 divided by 5. And if we were to do this long division, first thing we would say is, okay, 5 go into 1, 0 times, right? All right, does 5 go into 12? Yes, it does. It goes in 2 times. So we'd say 2 times 5 is 10. And we have the 12. 12 minus 10 is 2. Boom, right? Okay, and then we bring down the 8. Remember, bring down the 8. Okay, now we have 28, and we have 0, 2. And how many times does 5 go into 28? Well, it goes in 5 times. 5 times 5 is 25. 28 minus 5 is 3, and you have a remainder of 3. That is how we did long division back in 4th grade. Well, we're about to do long division on polynomials, and this process that I just went through with you is the exact same process. If you can remember how to do this, you can remember how to do this. So let's talk about it. Oh, a couple other things. When we said back in the day we'd say remainder 3, that means that it's 25. The answer for this problem would be 25 remainder 3, but what that really means is 25 and 3/5. You could just take the remainder and put it over whatever you divided by. Okay, and then over here, this is just a couple of some phrasing here. It says, remember what division means. 8 divided by 2 equals 4, right? So if you take 8 divided by 2 equals 4. Therefore, that means that 2 times 4 equals 8. That means 2 and 4 are both factors of 8. So if you divide one polynomial by another, and there is no remainder, then the divisor expression you divided by, the expression you divided by, is a factor. So if you divide something and it works out nicely, then that means that that thing is a factor of what you divided. So we'll get back to this. This will probably come in handy when you're doing one of the skills on con where they use some of this vocab and it gets a little tricky. But let's just talk about long division for right now. Okay. So it's already set up. We're doing x squared minus 3x plus 1 divided by x minus 4. So here's the deal, though. We need to make sure of a couple things. We need to make sure that all of the places are accounted for. And what I mean by places, I mean the highest exponent down. So notice that the highest exponent here is 2. So that means the next term should be an exponent of 1, which it really is, right? When there's no exponent there, it's 1. And this one doesn't have an exponent at all, so that's really like x to the 0. Now you don't have to write in these ones or this x to the 0. I'm just showing you, here's the highest exponent, and we have a 2, a 1, a 0. So this one is ready to go. Same thing here. This one is a 1, and then an x to the 0, so this is good. It's just, you starting from the highest one, you have to be able to count down. It can't go like 2, 0, or 2, 1, and then nothing. It's got to always have all the degrees have to be accounted for. So let's say the highest one was 5. The next one should have to be 4, 3, 2, 1, 0. So if there's anything missing, you're going to have to put in a placeholder, and I'll show you that later. But this one's good and this one's good, so we're ready to go ahead and divide. Now, this seems super complicated, and students always get really confused here, but just remember, we're doing the exact same thing that you did in the 4th grade. No math is really different here, so let's not stress ourselves out. In fact, I don't even have to worry about this -4 so much. I really only care about what's going on in the very first term. That's all I really care about here. So let's go ahead and do it. What I'm going to ask is I'm going to say, okay, what would I have to multiply x by to equal x squared? Because I just care about the first terms for now. So x times what equals x squared? Well, that's pretty easy. X times x equals x squared. And so right above where I already have and just a normal x to the 1, I'm going to just put x. So x times x equals x squared. So what I'm going to do is I'm actually going to multiply by, and what you could do to kind of help yourself is you could maybe put like parentheses here, but I'm going to multiply x times this whole thing. So x times x is x squared. X times -4 is -4x. So I'm just going to put -4x. Okay, that was kind of like what we did in the very first step here, right? We said, I mean, obviously this one had a 0, but like we said, okay, 2 times 5 is 10, right? So 2 times 5 is 10. Look what I did next. I subtracted, right? 12 minus 10. The only thing here is we're subtracting a whole term. So I need you to think of these as like having parentheses and then a minus. And just like we did before, it might help you if you distribute that minus sign. So if we distribute that minus, that becomes negative, that becomes positive, and then I could change that all to a plus. And look what happens now. X squared minus x squared, well, hey, that's just 0. Beautiful. And -3x and +4x, that makes +1x. So I'm going to say plus x. Okay, so I've done, this is just like the 12 minus the 10 here, right? 12 minus 10, I got 2. This is like x squared minus 3x minus x squared plus or minus 4x. When I subtracted it, it turns into -x squared plus 4x. And this is what's left over. So what was next now? I brought down the 8, right? So let's bring down this 1. And so now I'm going to do the same thing. I'm going to do the same process over again. Remember before I said what times x equals x squared? Well, what times x equals x. I'm only looking at the first term here. Well, that's easy. 1 times x equals x, right? So I'm just going to say 1. And I'll put a little plus there because it's +1. So 1 times x is x. 1 times -4 is -4. Again, I am subtracting, so it may help to actually distribute the negative. Then I can turn that into a plus. That becomes 0. And 1 plus 4 is actually 5. At this point, there's no more terms left to divide, right? I got the x to the 1 above the x to the 1. I got the x to the 0, right? Because this is like x to the 0 above the x to the 0. And all I have left is a 5. So I can actually just bring this 5 up and call this remainder 5. And there's my answer. I could also write this as, like I said before, remember we said if you had a remainder 3, that's like saying 25 and 3/5 because you divided by 5. Well, I'm just going to put what I divided by on bottom. So I could call this, also call this x plus 1 plus, since my remainder is 5, I'm going to put 5 on top divided by x minus 4. And there we go. There you have it. Okay. I know it's new. I know it's a lot to think about, but I think you guys can do it. I'm going to just kind of get you started on practice number 2 and see if you can't keep going from there. So let's talk about practice number 2 now. Okay, so remember, the first thing that you're doing is you're just looking at the first terms. I'll even highlight them. And you're saying what, right? What times x equals 2x squared. Oh, we should also look at the exponents. 2, 1, 0, 1, 0. We're good. This one's ready to go. No placeholders needed here, but you'll see some on the next page where we need some placeholders. Okay, so what times x equals 2x squared? Well, this is like a 1, right? So I'm obviously going to need a 2. And then I have an x to an x squared. I'm going to need to multiply by another x. So I think it's 2x that I'm multiplying by. So 2 times 1 equals 2. X times x equals x squared. Yes, 2x times x equals 2x squared. All right, so let's go ahead and do it then. Remember, I'm multiplying by this whole thing. So 2x times x, yes, that's 2x squared. 2x times negative 8, well, 2 times negative 8 is negative 16. So we're going to say negative 16x. Okay, and this is a part where a lot of people get confused, but remember the next step is you're actually going to subtract. So put parentheses around here and subtract. And then you're going to distribute that negative. I'm going to stop here. I'm going to let you finish this problem on your own. Think about the remainder. Think about how you can write that and go. And then you could unpause the video when you're ready to check your work. Okay, this one ended up working out perfectly, that it was just 2x minus 3 with a remainder of 0, remainder 0. That means that this divided perfectly with no remainder. So therefore, 2x minus 3 and x minus 8 are a factor of this big trinomial here. If you were to multiply these two things back together, like we did in the previous notes, you'd get back exactly what we started with. And we could kind of do that really quickly because we know how to do the box method, right? So we could say x minus 8 times 2x minus 3. And this is a good way to check your work as well. You'd get 2x squared, 2x times negative 8, negative 16x. Negative 3 times x is negative 3x. Negative 3 times negative 8 is positive 24. So I have 2x squared. These are like terms. That's negative 19x plus 24. Hey, that's exactly what we started with, right? So that means that this is a factor of this trinomial, and this is a factor of this trinomial. That's beautiful, because next chapter we're going to talk a lot about how to find factors. Okay, so we just did those two problems, long division. Let's go to the next page. And now we can see a situation where we're going to need some placeholders. So I'll show you what that looks like. It's going to get a little crazy here, but that's all right. I think you're up for the challenge. So let's go for it. Okay, so I'm going to divide this x to the 5th minus 1 divided by x squared plus 1. But right away you'll see this is a 5, and I don't have a 4, a 3, a 2, or a 1. So when I write all this out, I need to put in these placeholders. Same thing here. I have x squared, but I don't have x to the 1. I do have x to the 0, but I'm going to have to put in placeholders. So let me show you what that looks like. X squared plus 0 x to the 1 plus 1 divided by x to the 5th plus 0x to the 4th plus 0x cubed plus 0x squared plus 0x, and then finally minus 1. Since we're just putting in zeros as placeholders, because really if you were to kind of simplify this all out, wouldn't this just be x to the 5th minus 1, because these are all just 0? And wouldn't this just really be x squared plus 1? It would. And so this will divide nicely now. If we don't put in those placeholders, though, it won't work. Long division doesn't work. So let's go ahead and go to the problem now. And just like before, I'm asking what up here times x squared equals x to the 5th. Well, I have x times x, and here I have x times x times x times x times x. So I just need 3 more x's, or x cubed. Well, hey, there's an x cubed right there. So right above that, I'm just going to write x cubed. Okay, let's go ahead and do it. X cubed times x squared, that's x to the 5th. X cubed times anything with a 0 coefficient is really just going to be 0, but we'll call that 0x to the 4th just so we can put it in the right spot, right? Because there's kind of a 1 there. And then x cubed times 1 is 1x cubed. Okay, remember I'm subtracting this whole thing, right? So as I distribute this negative, 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 that becomes positive. I can just add straight down. Well, that turns into 0. This is already 0. And 0 minus 1 is just negative 1x cubed. You don't really need the 1 there, but I'm just kind of trying to make it kind of clear what's going on here. All right, these are now obsolete. And this is where it could be a little bit confusing, because before we only brought down one term, right? But look, I have one term here and I have 3 here. So I need to bring down the next 2 terms so that I would have 3 total. So let's just go ahead and do that. So that's plus 0x squared and then plus 0x. And I'm again going to ask, what times x squared is equal to negative 1x cubed? Well, I'm obviously going to need a negative 1, right, to make this negative 1. And I'm going to need another x because I have x squared, x cubed. So I think it's just negative 1x. But since I brought down 2 terms, I'm going to leave a little space here. And then I'm going to put the negative 1x here, because remember, I want my degrees to line up, right? X cubed, x1, x1. Okay, so negative 1x times x squared, that's negative 1x cubed. Negative 1x times 0x, that's 0x squared. Again, we don't really need the squared there or the x squared. I'm just kind of using it as a placeholder. And negative 1x times 1, well, that's just negative 1x. Remember, I am subtracting this whole thing. So if I go to distribute now, that becomes positive, negative, positive, and that now turns into a plus. And we see what happens here. This is really just like 0. This is also just like 0 because 0 minus 0 is 0. And this is like 0 plus 1. And so this is just 1x. And I could bring down this negative 1. I brought down that before. And we see now that we're out, right? We're out of terms here. It's this degree is higher than this degree. We're not going to be able to divide anymore. And so again, I'm going to just put like a plus 0 here. And now this is like my remainder. And so I could write that the answer to this is x cubed. I don't need to put in all the placeholders for my answer, just for the long division. So x cubed minus x, remainder, x minus 1. Or remember that the remainder could also be written as x minus 1 divided by whatever we divided by, which was x squared plus 1. Boom. And that's it. I know it's a little bit long, kind of a tedious process, but it's very doable. It's just the same thing over and over again. So I want you to try practice number 3 on your own, and then unpause the video when you're ready to check your work. Remember all the placeholders that you need, right? Okay, it was kind of a long problem, but here's what you should have. X to the 4th minus 3x cubed plus 9x squared minus 25x plus 75 with a remainder of negative 226. Whew, a lot of work. Here's all my work there. You may want to pause the screen. That's my son telling you, hopefully you did it right. Now if we go down to example number 4, we're actually going to do the same. It's the exact same problem that we did on the previous page, same as example number 2. Only here, we're going to do something called synthetic division. And I think some of you guys are going to like this a lot better. It's definitely simpler and definitely a lot quicker. But the problem with it is it's only quicker when the coefficient is a 1. When it becomes anything, the first coefficient what you're dividing by is, if that's anything other than a 1, it definitely gets, you can still use synthetic division, but it's just not quite as simple anymore. But nevertheless, let's show you how you do it. First thing we need is we need to know the 0 of what we are dividing by. What I mean by that is, when would this equal 0? And that's pretty easy. It's just the opposite of whatever number this is, right? Wouldn't this whole thing equal 0 if this was positive 4? Because 4 minus 4 equals 0. So we found the 0 of this, and we're just going to put that number in the top left corner like that. Then from there, we're going to list all the coefficients. Again, make sure we have all our placeholders, right? 2, 1, 0, so they're all there. All the coefficients we're going to list right here. Well, the first coefficient is 1, then negative 3, and then positive 1. We're going to leave kind of a row of space, and I'm going to put a box right down here in the bottom right corner because this is going to be the remainder. All right, all we got to do is we just bring the first term down. That's just a 1. And then we just multiply and add. 4 times 1, that's 4. So I'm going to put a 4 here. And now I'm going to add straight down, negative 3 and 4, that's a 1. Okay, 4 times 1, that's a 4. 1 plus 4 is 5. So that means my remainder is 5. Now, what I have to do here, this is the part that's maybe a little confusing. Remember I said we need every degree down to 0. Remember, this is really like x to the 0, x to the 1, x to the 0, x to the 1, x squared. Starting from the right, this is going to be like x to the 0. This would be x to the 1. And if I had more terms down here, I'd have x squared, x cubed, and so on. And so as we simplify this, or we write this out kind of in like normal math language, we could say that this is really just, well, 1x to the 1, that's just x. And then a positive 1x to the 0, well, that's just plus 1, because x to the 0 is just 1, so 1 times 1 is 1, plus a remainder of 5. Or we could also say, remember we said x plus 1 plus 5 over whatever we divided by, which was x minus 4. And if you take a look on the previous page, that's the exact same answer that we got. So this is synthetic division. As you can see, it's a little bit smoother, a little bit cleaner, a little bit quicker. But for now, we're only doing synthetic division where the coefficient of what you're dividing by is 1. See how those are all 1s? If that becomes like a 2 or a 3, you could still do synthetic. There's just some extra steps to think about. So, all right, I want to do one more with you guys to kind of walk you through it. We got another one here. And I think this is the one that we did on the previous page as well. So remember, the first thing is we want to know the 0. Hopefully you could tell me what's the 0 of this thing. Well, what minus 8 equals 0? It'd be 8. So 8. Then we put all the coefficients. I don't have a need for any placeholders because they're all there. X squared, x to the 1, x to the 0. So that's 2, negative 19, 24. Leave a space. Box. Remember that box is for my remainder. Okay, I'm just going to bring down the first one. That's a 2. 8 times 2 is 16. 16, negative 19 and positive 16 makes negative 3. 8 and negative 3, that makes negative 24. 24 minus 24, that is 0. Okay, remember this is going to be x to the 0. This is going to be x to the 1. So if we were to simplify this, this is really just 2x minus 3. And the remainder is 0, so I don't have to worry about, you know, any weird fraction at the end or a remainder. It's just that. And we're done. 2x minus 3 is the answer. Pretty cool. Synthetic division is actually pretty nice. Just a good little skill to have in your back pocket for some problems. All right. Let's try this one. I want you to try this one on your own. I'm going to draw out the boxes for you, right? It's going to look something like this. You're going to have a long row. And then remember at the end here, you're going to have a box. Okay. So think about what your 0 is, think about what goes here, and then you just bring down the first one, multiply and add. Go ahead and give it a try, and then check back in a second to see if you did it correctly. All right, so here, that would have been your 0. Negative 1 plus 1 is 0. Then we have a coefficient of 1, 4, 1, negative 6. Bring down the 1. Negative 1 times 1 is negative 1. 4 and negative 1 makes 3. 3 times negative 1 is negative 3. Add that up, you get negative 2. Negative 1, negative 2 makes positive 2. Negative 6 and positive 2 makes negative 4. So we just put the x's in with the, I guess you would say the descending exponents. You got x squared, 3x, and negative 2. And then remainder negative 4, so you could write that as x squared plus 3x minus 2 minus 4 over whatever you divided by, which is x plus 1. All right, so that was a little bit harder problem, and it was still quite a bit simpler using synthetic division. So I'd encourage you to practice using both and figure out which one works the best for you, but you will have times when you need to do both. So you definitely need to know how to do both, but you know, it's okay to have a favorite. All right, last thing here is a summary. I want you to describe the difference between using long and synthetic division. Explain which method you prefer and why. See you guys on the next video.